I think this is working. I am recording this so that anybody not synchronous is able to review this after the fact. Where is that? I haven't tried this new camera. Hopefully this will all work out. We're practicing dilations in particular, but don't forget the rotations, reflections, translations. Am I forgetting any? No? Okay. Anyway, let me just see if I can switch the camera here. Hopefully this will work so that it all it will become working. Let me try this. Is it working? Hey, it's working. It looks like it's working. Cool. So we're going to be doing some translations and so on. I think that's the right way up. Wow. Second. They took away my software that allows me to do this properly, unfortunately. So it's the best we can do. Okay, so today what I want you to do, and you can follow along with this, is go ahead and make yourself an axis and offset this. So you need to make sure you're well offset. And we sort of did this last week, but I want to show you again and take it to the next level is kind of my goal here. And make it a relatively large axis. There's your Y, there's your X. And in particular, today we are going to be talking about a particular kind of transformation called dilation. And so the idea is you take a shape and you explode it. Kaboom! All right, so let's build ourselves a little shape here. And the benefit of the Cartesian system is whatever shape I choose to make, you can end up with exactly the same shape if we do this right. So I'm going to do a quadrilateral shape, and we're going to call that A, B, C, and D. And we'll connect those in a second. But let's start by writing down the coordinates. So coordinates for A, B, C, and D. So please jot down those coordinates. I know it's a bit hard to see up on the big screen, so I'll zoom in a little. What's the coordinate for A? Can you see from where you are? 2, -1. Thank you. And B? I know, it's a bit hard to see on the big projector. 1, -3. And then we've got C would be 2, negative, I think that's 5. And D would be 4, -2. All right, so those are our coordinates. You can tell because they are listed in the circular, like the rounded brackets, which are officially called parentheses. All right, so go ahead and build your shape just like that one. And we're going to now manipulate this shape through transformations. We're going to start off with dilations, but we'll get there soon enough to the other ones. I'm just going to connect that up to make myself a nice little shape. So go ahead and build this along with me, please. And I've already mentioned, I do prefer to actually color these in when you, so if you've got some pencil crayons, you're more than welcome to do that. Or markers. Color in the whole shape. Isn't it pretty? All right, so dilations work as follows. We're going to dilate this, and we've done this before, but we're going to take this up a notch as well. So you're going to be asked to dilate from the origin by a factor. We're just going to do 2. 3 starts to get a bit off the page. We could do 1.5 if we wanted to do something exciting, but I think we'll just do 2 for now. That sounds. What do you want? 2? All right. So we're going to dilate by a factor of 2. And I left enough space here that we can kind of show what our new coordinates would be. So go ahead and determine what your new coordinates would be. Remember, it's a factor of 2. So that's going to be multiplying. And you're going, the quick way to do this is, since we've got these anyway, we're going to multiply each of these xy coordinates, by 2. Sort of like when we were doing proportional reasoning. So go ahead and determine what those would be. And I'm just going to write them over here because we're probably not going to use quadrant 3. Go ahead and map that out. I'll wait. Yes, please. I mean, if you want to do another one after this, you're welcome to if you've got some time. You can even do it on the same grid. All right, so I'm going to start multiplying these by 2. So just a quick reminder, for our nomenclature, it's A prime, and we put the little tick to indicate that this is the image of A after it's been dilated. Okay, and get the coordinate for B prime, C prime, and D prime. And just verify all of those. Okay, now that we've got them calculated, our dilation coordinates. Now let's plot our dilation coordinates. And remember, this time, on the use of the word this time, we are dilating from the origin. So it's going to be dilated out by a factor of 2 from the origin. Now that might change in our next example. So let's go ahead and plot these new ones. Oh, we got a double. When they double up like that, just move the label slightly and you can see that that's going to be in the same spot. Okay, and B. And C. I think that's C. D prime. And D. I think that's it. And all right, now you can probably guess as to why I chose to use some color in this. As you start to map this out, it'll become apparent. And I'm just going to just outline this. I'm not going to do the whole thing. Is that what you got? All right, a couple things before we move on. I know I've mentioned this before, so I apologize for the, whoop, as I bashed the microphone. I apologize for the repeat, but I do like to point this out. If you draw a line between, I don't know, B prime and the origin, the point by which it is being dilated, you will see that dashed line passes right through the old original image of B, or the original point of B. And A, it's a little hard to see, but you can see that it passes right through. Same thing with D, except it's right along that line. So it's just going to mimic the line that it's on, and then C. Take a second to try to align that as best I can. And A is already there. Okay, so here you can see that it passes right through the old point and then continues on to the origin. Cool? All right, now last time, the next thing we're going to do is we're going to take our original right there, and this time I'm going to ask you to dilate it by a factor of 2, but we're changing where we're dilating from. All right, we're taking it up a notch in terms of difficulty. So that's the step 1, number 1, was to dilate from the origin. And technically, that's all you have to do in grade 8. Ta-da! Double, right? And also notice the size is double of the lengths. Quite literally, if I take my ruler, I can do that. I can double the length. You'll see this one's 4.5. The original was 2 and a little bit, like 2.25 probably. Cool. So the side lengths are all doubled. The angles are all going to actually be identical, right? So this one's almost 90. Lo and behold, that one is also 90, and so on. So the angles is a little over 60, and that one is also a little over 60. So you can see the angles are congruent between the two, and the line length is now doubled because we have increased by 2. So just for fun, let's try dilating this, the original, from the point 0, -4. So we're going to dilate it from 0. This is the second one. So please dilate this from the point of dilation 0, -4, and we're going to see what happens when we this becomes our point of dilation. Here's a hint if you're not sure how to handle this. Just pretend this little slidey thing is our original grid, and we're moving it down so that it's as if it was here, right? So your new points are for the original are right there. So you can determine what that is. This is how I would do it. There are probably many ways, but I'd take these original points here and basically get rid of them in your mind for now. And instead, imagine you have slid this down to here, and these are your new points. You could also algebraically figure that out because you're effectively doing a translation of 0, -4. So you would have the opposite effect. If you slide the grid, all your points are going to go the opposite of 0, -4. So what's the opposite of 0? 0. There's no change. What about the opposite of -4? Would be 4. So go ahead and take a little bit of time to figure out your new points, and then you dilate it by a factor of 2 again. Still going to be a factor of 2, just a different point of origin. I will leave this up here in case anybody needs a hand determining your new points. I feel like I need a little weight on that to keep it down, but I'll just align it as best I can. Easy breezy? Too hard? Yeah? There's another thing that I want to show you after this that I think was really neato. We'll do that in a bit. All right, how's it going? How many people need a few more minutes? Okay. If you're done early, I want you to do the following as well. Okay? So if you're done early, I want you to take that Post-it note I gave you and look at your original shape. And I want you to actually, you know what? We'll do that after. Well, no. Let's do it now. I only got one shot at this. Let's make it count. So my goal is to align these Post-its just so with the axes. All right, and I can see through it. If you do this right, you can see through it. So you can still mark your original points. So there's C, B, there's A, there's D. And I also want you to mark the little tick boxes indicating where it aligns with your grid. Okay, and if you want to, you can draw the original, you can trace the lines or just connect the dots. It's connect the dots time. In this case, literally, not figuratively. All right, and it's not a bad idea to label it, just so we can keep track of which points are where. See, now I've got a copy of this. Cool? All right, let's just set this aside for now. We're going to come back to this in a minute. Going to get my point of origin overlay grid thing that I made here from an old discarded face mask. Not the kind you, like face shield, I should say. Okay, keep on keeping on. Where does that end up? I'm going to do mine now, too. It also might be useful with that Post-it. I'm just going to jot on the back my new coordinate points. If they are all moved down by a translation of -4, I'm doing the opposite to the points. So these are moved up by 4. So the x stays the same. The y changes to be 4 more than that. So it would be, and I can just verify this, -1 would become 3. -3 would become 1. That would be -1. And that would be +2. And you can verify that if you've got this little slidey grid. If you need that verified, you can double check that you've got your coordinates correct with the little slidey grid on top. You can say, okay, B is 1, 1, 2, 3 for A, 2, -1, and 4, +2. Okay, so these are my translated things. And now we do the factor of 2, except this time from a different dilation point. Okay, so now I have my short version of that. Oh, and this will be double prime, by the way. 2 little ticks. Cool. Now I just need to map those. I wish I had like an option to do fast forward in real life. Oh, am I off my map? I might be off my map. Oh no. Oh no. I'm way up here. How did that? No, that can't be right. Is that right? Oh, I know why. Ha ha ha. I messed up. Well, not really. From this point, I now have that. And now I need to undo my translation. So the x stays the same. After translation, that would be 4, and then take away 4. You got to put your translation back. So it's like we translated it down, meaning all these points, by comparison to that origin, have moved up. Once you now double those, you got to move it on back. by taking away that initial translation of -4. At least that's what I'm doing. Maybe you found a faster way. Anybody have a faster way? No, that's what everybody did? Okay. Well, I'm glad I'm not the only one. That makes more sense than what I had before. So I'm glad. Okay, so now I've got my new points as if I have slid this grid back up, and I can now plot them. Okay. That's better. It fits on my map. Okay, and now I can draw my shape. And if all goes well, it should be the same size. But now it's from a different location. So what I mean by that is if I were to draw those lines like we did the first time through the points to A prime, it is now radiating out, as it were, from a new location and passing through the old and out to the new. So for each of these, from that point of that translated point of reflection right there, that is now I'll put that as orange just so people can see. Okay, and we're almost done. Ah, messed up. Okay, good enough. Good enough. Okay, and what do you think? Should I make this one orange? I'll just outline it in orange just so we can kind of see it. Congratulations, you've officially gone above and beyond. So from here projecting this way, and then this one is projecting this way. All right, last thing, and remember that post-it note I wanted you to make? Hopefully it's still working. Where'd it go? There's mine. This one? How many people have done that? You got that handy? Okay, so I just want to try this for fun, just for fun. Let's line that up, and you can kind of see how that original yellow, that should be aligned perfectly, yeah? Now, any guesses about how to make this the same size as either one of those? How would I make this the same size as this? From this perspective. It works really nicely from the camera, actually. Without redrawing it. Yeah, what do you think? I can maybe move it higher. So I can try to keep the orientation the same, and I can try to hold it up closer and closer to the camera until it becomes the same size as the others. Now, it's going to involve a little bit of creative. I'm just going to fold this down so we can see it a little better. All right. So, what do you think? Is that pretty good? Pretty close? Yeah. I could use a magnifying glass. I could increase the, absolutely. Out of curiosity, this is a little more obvious live. How far up do you think I'm holding that? Well, I happen to have the ruler. Let's find out. So you tell me when it appears to be the same size as that orange box. Right around here? Interesting. Okay, okay. What do you think? Is that, I know my fingers are kind of in the way, I'm sorry. What do you think? Is that about the same size? I think it's almost a bit too much. How about right about there? Is that it? What do you think? Yeah? A little lower? How about there? That looks about the same as the pink one, yeah. And if I hold it over there, still a little too high. All right, interesting. That's the same result that I got last time. So I was holding it at the 22 centimeter mark. 22, oh, sorry, it's really hard to see on the camera. 22 centimeter mark is where I was holding this up, and it appeared to be the same size as this. So 22 centimeters up off the desk. Oddly enough, I tried this downstairs with with one of my other classes, and I got the exact same result with a very different shape. So here's the one. Here's one I made earlier, um, and notice something. So here's my little itty bitty one, right? It's the same as this, and I hold it up, and I can almost do this without even looking. Now I can just go boom. Here's my centimeters, and I'll just slide it up until it looks to be the same size as that yellow one. Right about there, right? And if I'm holding this, you can see, again, it's at about the 22 centimeter mark up off the page. Isn't that weird? So if I increase this by 22 centimeters on the, which axis is that? That's the Z axis, right? And if I increase it by 22 centimeters up, it appears to be approximately double, as if I were to have dilated it by a factor of 2. Now, it's one shape, that'd be kind of interesting. 2 shapes, okay, maybe this is a thing. I have another one here where I already did the yellow. You can see that's the same as the yellow. And if I were to now try to make it the same size as the pink one, and again, where do you think I'm going to hold it up? 22. Now, and again, if I'm holding it at 22, and I'm matching that where is it, the pink one, right? And again, that's about the same size at the 22 centimeters up the axis this way. Just, I don't know. I feel like there's something to that. I wondered if it was maybe the size of the shape. That's why you guys were my guinea pigs. But 22 seems to hold. Yeah, what do you think? Yeah, that's true. It may have to do with the ratio of the difference between the camera and here. So maybe we can change that. I don't even think I have 22 centimeters there. Let's try this here. So here's my, and I'm just going to skip right ahead and let's see. I'm going to hold it at 22 centimeters, and it should appear, if I'm orienting this right, it should appear pretty much the same size as the orange. Hold on. Right about there. Oh, hold on. It's really hard to see because there's so much overlap. Let me fold that down. So at 22, right around there. Oh, maybe it has, maybe that is it. Maybe it's about the perspective of how far away from that it is. Right about there, right? Oh, I think you might be onto something. This one's only 17. Huh. How far away is the camera, I wonder? Camera's 28. I bet you there's a proportional relationship there. What? It might be. What is that? What's 17 divided by 28? What was that? Okay. Okay. All right. I'm not. Or perhaps it has to do with the size of the grids. I don't know. Anyway, if anybody has any ideas about that, I was thinking it's kind of cool because you're talking about perspective in another axis, which is a very interesting thing to me when you're talking about dimensions. All right, thanks very much. This is Dilations. Hopefully it makes sense to you. Now we're gonna play some Battleship. So we're gonna watch a video I did earlier about playing Battleship using Cartesian plane. So that's what we're gonna do next. Questions? Yeah. Yeah. Whoa! Seriously? Yeah, it's about 1.61 something. So that's pretty close, especially because I wasn't including decimals. Huh. Maybe it's that golden ratio yet again. I don't know. Check it out for yourselves. Check it out for yourself. And we'll see you later. Bye. I'm going to stop recording now. Thanks.